analysis of variance, Anova. The one-way analysis of variance, or one-factor analysis of variance, is where we have one independent variable of interest, which is a difference amongst groups. In this case, we'll have multiple groups in an experimental or quasi-experimental setting. We'll assume for now random assignment, possibly random selection from the population, and the levels we have chosen ourselves, so we will consider them fixed. The level differences between the groups. And we want to know, is there really a meaningful, or is there a significant, in this case, difference amongst groups? Similar to an extension of what we did in our t-tests. But we're not just doing a t-test anymore. There's more than two groups. We can use an analysis of variance for two or more groups. Alpha, for many comparisons with a lot of t-tests, becomes undesirable, and our experimental-wise error rates become unmanageable. That is, for a t-test, if we set our significance level, our alpha, at 0.05, for one t-test, it stays 0.05. But for example, with 5 groups, if we wanted to make all possible comparisons, we would have a 0.40 experimental-wise error. Let's consider the null hypothesis. When we were dealing with t-tests, we had, for example, 2 groups with the independent t-test, and we examined the means to see whether or not they were equal. Our null hypothesis, a hypothesis about the population values, said previously with our t-test that mu1 equaled mu2, or that the mean of group 1 in the population would equal the mean of group 2 in the population. In dealing with analysis of variance, we have more than 2 groups often. We can have 2 or more. So our null hypothesis is effectively that all of the means in the population should be equal. The alternative hypothesis, which is likely to be consistent with our research hypothesis, simply says that for some group they will not be equal, or not all of the population means are equal. The philosophical change or theoretical change is going to be that we're not just going to look at one group to start. We're going to look at an omnibus test for analysis of variance in the beginning. Later on we'll talk more about multiple comparisons, but for now we're going to want to see whether or not there is a difference between groups that is large enough that it outweighs the difference within groups. That is, we're going to look at a ratio of variances. We're going to look at within group variance, the variance within each group, if we were to add up those variances across all those groups, and the variance between groups, that is, the difference that separates the distributions, the means of each group. And we're going to see, is that between group difference greater than the within group difference, or meaningfully greater? We will learn more about the F ratio. This is the ratio of between group variance over within group variance. We'll learn more about what that MS means later on in later videos. But we can also think about this as the ratio of the treatment effect over error. How much of the effect of being in a different group or a treatment group was meaningful or significant?